Hello and welcome to this video in which we are going to understand the problem bathroom stalls from a Codejam competition published in 2018. To start with, let us look at the vocabulary that we need. We need guards that will be represented with a red G. We need empty bathroom stalls that will be represented with a green circle. And we need occupied bathroom stalls, which will be represented by a green circle with some pink inside of it. Now, let us look at some examples. Here you have an example of two guards guarding at the leftist position and the rightist position one bathroom stall. Here there are no guests yet. Now we are looking at a very similar example, except this one has got one guest. As you can see, K is equal to 1. The guest goes to the unique bathroom stall. Now we have the example where two bathroom stalls are available. Now the example where one bathroom is occupied and one is available. You can notice that the guest has chosen the leftist one, as it is mentioned in the Codejam problem. That is, in case of a tie, choose the leftist one. Then we see the case where there are two bathroom stalls and two guests. Naturally, they occupy all the stalls. Here, we are trying to understand how the guests choose their bathroom stalls. The way they do it is by going to a stall that is as far as possible from the guards and from the other occupied bathroom stall, if there are any. So let's look at the case where there are initially 3 bathroom stalls and no guests. K is equal to 0. Then, when there is one guest, he naturally sits in the middle of the 3 places. When there is one other guest, he will choose the leftist option, that is the first one when we read from left to right. And when there is a third guest, he will have to go to the only available bathroom stall. Now that we understand how everyone chooses their stall, let us try to solve the problem with another example. The problem goes, when K guests have entered the bathroom, what is the maximum number of stalls between the last guest and the other guests, or guards? And what is the minimum number of stalls between the K's guest, the K's guest, and his neighbors, or again, guards? With the example where n is equal to 4 and k is equal to 1, the answer is 2, 1. Indeed, there are 2 available bathroom stalls on the right side of the guest and 1 available on his left side. With n equal to 4 and k equal to 2, the answer is 1 and 0. Indeed, when the second guest arrives, there is 1 free stall at his right and 0 free stalls at his left. N equal to 4 and k equals to 3 gives the result of 0 and 0. Indeed, when the third guest arrives, he takes the stall number 1 when we read from left to right. So there is no place available on his left side nor on his right side, as you can see. And when n is equal to 4 and k equal to 4, obviously the answer is 0, 0. There are no seats available on his left side nor on his right side when the fourth guest goes to the stall. Now that we understand how everybody goes to every place and that we get what answer is expected from us, let us look at this problem from an algorithmic point of view. Let's consider the example where we are given 10 bathroom stalls, 2 guards, and where the number of guests will reach 5. We are using a priority queue to solve this problem. We start by pushing the number n in it, that is the number of free consecutive bathroom stalls. Now, one guest has arrived in the bathroom. He will choose the fifth stall, and if K was 1, the answer would be 5 and 4. So we retrieve 10 from the priority queue by doing a simple priority queue dot pop, and we push it the values of 5 and 4 by doing a priority queue dot push. Now a second guest has arrived. He goes to the middle of the 5 available bathroom stalls. If K were equal to 2, the answer would be 2 and 2, because we had 5 consecutive bathroom stalls and we took one of them. So that leads to 4 empty stalls, 2 on each side. We retrieve 5 from the priority queue by doing a priority queue dot pop, and we push it the values 2 and 2. Now a third guest is arriving. We retrieve the biggest number of consecutive bathroom stalls by doing a priority queue dot pop. If K equals 3, we would print out this number divided by 2 twice. The number is equal to 4, and as it is an even number, it gives the answer 4 divided by 2 and 4 divided by 2 minus 1, that is 2 and 1. As K is greater than 3, we push 2 and 1 into the priority queue, and we increase the number of guests. Again, we retrieve the biggest number of consecutive bathroom stalls by doing a priority queue dot top. We know that K is greater than 4, so we push back this number divided by 2 in the priority queue. As the number is 2 and 2 is even, we push 2 divided by 2 and 2 divided by 2 minus 1 into the priority queue. We increment the number of guests. Now, K is equal to 5, so K is equal to our number of guests. What we do is that we retrieve the maximum number of consecutive available bathroom stalls by doing a dot top on our priority queue, and we print out this number divided by 2 twice as our answer. This number, that we can call x, will get divided by 2 according to the fact that it is even or odd. In this case, x equals 2, and so the result will be 2 divided by 2, that is 1, and 2 divided by 2 minus 1, that is 0. Now we can see how the algorithm should look like. Don't forget to check if x is odd or even, as the values of x1 and x2 depend on it. Thank you for paying attention to this video, and bye.